Yo, what's up, everyone? For the second problem set for week 3, I'm just going to review what we did for the past 2 weeks because I looked kind of back at the last video and I thought it was pretty challenging what we did, and we're crushing it so far. So I think it's better to slow it a bit and make sure we're all solid, because last lesson was definitely the hardest lesson we did, and we know we're talking about piecewise functions. But before we go back to doing some review of the piecewise, I just want to start all the way back at lines, okay? This video is going to be short and this worksheet is going to be pretty light, and it's all going to be review. So drawing a line is pretty easy, right? Finding the equation of a line is pretty easy. But what makes it so difficult in a piecewise function is that you're not given the entire graph. Okay, so first, anytime you have to write an equation, we know we want it in y equals mx plus b form. Okay? So when you're writing your piecewise, it's either going to be y equals mx plus b or just a number that represents a horizontal line. Okay? So you want it in mx plus b, where m equals slope and b equals y-intercept. Now, let's talk about where that can be tricky. Okay, so for this example, we're given the whole graph, but just to show you, I'm going to remove most of it. So let's ignore the entire graph, and let's pretend that we're doing a piecewise where this is our entire part. The whole thing is present, right? And the equation would represent the whole thing, but let's say we were only given this. How can we figure out the equation with only part of the line? So first, we should look to find 2 points. Okay, so I actually just extended a little bit to think. But if we want to find the slope, all we need is 2 points that are exactly on the line. Okay, so this is exact, this is not exact, this is not exact. So you have to look to see where is it going exactly onto your graph. No, no, no. We found a point here. Okay, so no matter where or what you're given on the graph, find 2 points so that you can find the slope. Okay, and from those 2 points, we could use the slope formula, y2 minus y1 over x2 minus x1, but I strongly prefer to use shortcuts at this point. Okay. So if I'm trying to shortcut to find the slope, all I have to do is find the change in y up and down and the change in x left to right. So from this point to this point, we moved over 4 in x. That's going to be the bottom of my slope fraction. And for y, we moved down 3. So because it's 3, we'll put a 3, but it's down, so it's negative. Okay, so my slope formula is always change in y over change in x. y2 minus y1 divided by x2 minus x1. So our slope is going to be negative 3 over 4. So if you're only given a part of your graph, the slope is going to be still pretty easy to find because all you need is to have 2 points. But here's where it's complicated, and here's the part that I definitely wanted to do again. So the second part of the formula is the y-intercept, okay? And if we were given the whole graph, this is so easy. The y-intercept is 5, okay? So we could just write y-intercept equals 5, y equals negative 3 over 4x plus 5. That's the equation. But sometimes when you have a piecewise, it's not going to show you what that y-intercept is. We can't see it on our graph, right? If you were given this, you could maybe estimate, you could maybe draw the line in if you had multiple sections. But let's talk about how we can figure out the y-intercept with just this section of the line, okay? And this is review too. This isn't a new concept. But if we ever want to find the y-intercept, think that we're trying to solve b. And if we want to find b, my bad. So this is the equation so far. We found the slope. But if we want to find b, all I have to do is plug in a single point into the equation. So it doesn't matter where you are in the graph. If you can identify a point, in this case, that point is 8 comma negative 1. That point we can plug into the equation and find b. And I always do the algebra at the end pretty quickly, but if you're multiplying a fraction to a number, that number is multiplied to the top. So negative 24 over 4. And that's negative 6. And we already did know the answer because we have the whole graph, but we've now found it with math. Okay, so again, the key to this is that you have multiple methods to find the y-intercept, and if you don't see the y-intercept, plug in a point to find it. Okay, so that's going to be really useful for piecewise, because imagine this is just one part of the equation, then it does something like that, then it does something like that. Okay, so we'd want to figure out that y-intercept, and then this line would have a different y-intercept, right? Okay, so that's one. We're doing really well on time, so I think this will be pretty quick. But for 2, it says look at the following equation, and we want to graph the equation when x is negative 9 to x is negative 3. So this notation is interval notation, and it's saying we're only going to draw the graph for a part of it. The same way we were thinking about the concept of what happens if we only have part of the line showing, now it's telling us to only graph part of the line. Because we know that sometimes we're given multiple equations, multiple intervals, and we have to graph all of those. So for this, let's first just figure out what the interval is. If this is negative 9, this is negative 3, all we're going to do is draw the line from here, wherever it may happen to be. And what makes this hard is the same idea as number 1. So usually when you draw a line, you start with the y-intercept, right? If you put like if we see this equation, we know the y-intercept is 2. We know that this point is part of my line, okay? However, we're not graphing that part of the line, okay? This point is not in negative 9 to negative 3. If we're drawing just this interval, it's not there. So how can we start this particular interval? And that, I think, is what was tricking people up before. And this is actually easier than you think, and hopefully this is pretty cool to people. But even before we learned the shortcuts, what was the second strategy we had to draw a line? And that idea is a table. So even before we knew anything, we could plug in random points into x and solve for y to plot it, right? Usually we plug in negative 1, 0, and 1 and find what it looks like close to here. But if we're trying to graph the interval negative 9 to negative 3, all we have to do is plug in the points in that range, and that's going to give us the line at that point. No use in just using the y-intercept and then the slope. Hopefully that makes sense to people, because I think that's really fascinating and shows that sometimes things are simpler than you even think. So if I'm trying to draw this line from negative 3 to negative 9, I'm going to plug those 3 points into my graph. So first, negative 1/3 times negative 3 plus 2. You catch my drift? We'll do that for each of them. 1, so this is going to be 3. It's going to be 3, 4, and 5. So you work out the math quicker, but you know, I do this for a living, so I get it pretty quick. But once I have my points, I can just plot that line. So we had negative 9, comma 5, negative 6, comma 4, negative 3, comma 3. I may have said one of those wrong, but these are the points. And that makes a lot of sense because it's going to intersect with that y-intercept. And you could have, in this case particularly, worked backwards from the slope to find the line. But I'm just trying to show you that you have a lot of options here. Okay? So that would be that part. Let me graph it. And we definitely don't put arrows here because it's just from this interval, -9 to -3. So that's all I'm going to do right now. But what I want you to think is that if you were ever given the full thing to solve, all you have to do is each graph individually on that interval. What we just did for this, think of that as one part of graphing an entire piecewise. Okay, so figure out what your interval is and figure out how you want to graph based on that interval. If you don't have the y-intercept, a table or just plugging in values works. You don't have to make the table as long as you know to plug in -3 and -9 onto the graph. Okay, that's all I have for you this week. Really short lesson.